Hello and welcome. In this session, we are going to learn some of the features of AWS Aurora for PostgreSQL compatibility. We are starting with the introduction, as we have already seen in the previous the slide, which was about the part one introduction of PostgreSQL Aurora. In that, what we discussed is Amazon Aurora is a relational database services, and it is under the flagship of RDS. It has been very popular in last few years because it is an open source. It has a high speed because of its high availability. When we're talking about the AWS Aurora for PostgreSQL, on the same hardware, when we use in Aurora PostgreSQL is 3 times faster as compared to your traditional PostgreSQL 9.6 when you use it on premises. It is because the fastest, or we say it is 3 times faster because of the intelligent hardware, networking, and other components which are used together, right? And when you are already using the PostgreSQL and you are coming to Aurora, you don't have to change anything. Your applications will continue to work the way it has been working in the past because it is same PostgreSQL compatible, so you don't need to change anything. So if you're considering to take off some of the enterprise databases from on-premises to AWS Aurora, it's a good time because you have the supported technology in terms of database migration services which can migrate the heterogeneous environment or the databases to Aurora PostgreSQL compatible, right? Then moving on to why this comes under the high performance and scalability. So when we say Aurora PostgreSQL is very fast, and when it is tested on PG bench, it has been found the same query which works on the on-premises 3 times faster in terms of the throughput, right? In terms of the provisioning and other stuff, you can use it with the push button compute scaling. So in case you wanted to increase the compute, you can do it. You can scale up or you can scale down. So it's very easy. The amount of the CPU or RAM need or you need to scale up or scale down, it's going to be very easy. Storage auto scaling. So you have a maximum limit of 128 terabyte. So I don't think there is a minimum limit. So every time you need extra storage, you don't need to ask for it or provision it. So it auto increments by 10 GB. So when it is shortage of storage, 10 GB of storage will be added to your current storage. So you don't need to do anything in terms of calculation for the storage, right? So you don't need to provision extra amount of storage. No wastage of storage. So whatever is required, it will be auto provisioned. One of the best thing over here is low latency read replicas. Replicas are required everywhere because they are useful if they have the read capability. So you can have 15 read replicas in PostgreSQL. So you will have the different endpoints. One is for the read operations, and another if you wanted to use it for the read and write. So you have the primary database, and rest of them can be used for the read replicas. And when we say low latency, it is because of the cluster volume. It is using the same cluster file system, so it will be used for the reading purpose. It is not normal traditional PostgreSQL wherein you create the replicas and you manage it. You don't need to do anything. It is at the storage level, and that is being used at 15 points. So there are 15 read replicas which can be used. This is a very good feature which is called as the serverless configuration. In case you don't want to manage the entire infrastructure related to this, you don't want to scale up or scale down, and you want to keep it down when there is no requirement, so you can use the serverless configuration. And this is for occasional users. If you wanted to use for permanent users, I don't think this is going to be a good option. Custom database endpoints. So you have primary database, which is used for read and write operations. You have read replicas, which can be used for the reads. So you can customize your application to use both for read and write operation, and the other is specifically for read. So 15 read replicas can be used. That is custom database endpoints. When we talk about the high availability and durability, the first comes is the instance monitoring and repair. So under the covers, it is going to use the EC2, and it has the SSD storage. So in case there is a failure of storage or the compute node or the complete EC2 instance, that will be terminated. And because it replicates 6 ways in the AZ, which is availability zone. So if it is a disk level problem, so that will be replaced by the new one. Or if it is the entire instance, then a new instance will be provisioned. Then you have the multi-AZ deployments with the Aurora replica. So you have 15 replicas that can be deployed in multi AZ. So and in let's say there are 3 AZ, so it replicates 6 ways, which is transparent, and you don't have to pay for that. That is for the high availability, right? Global database is a new concept which has been launched for Aurora PostgreSQL, wherein you can have the same database, the instance running in multiple regions. It is not just the availability zones, it can go beyond that. So each region can have 16 more, 15 more read replicas. Fault tolerant and self-healing storage. This is very good. So each storage, which is of 10 GB in size, if it is faulty, it will be auto healed and replaced. Next one is the automatic continuous and incremental backup. So when you enable the backup, you can have it maximum for 35 days, and when you wanted to have it point in um, restore, you can go 5 minutes back in past. So this is something new which has been launched. And you have database snapshots. In case you wanted to take a backup of your database manually, you can do it database snapshot, which is very fast. The incremental backups will be on top of it, and restoration from the database snapshots is faster. In terms of the security, it is advisable to have this RDS um, in a BPC, and you can have the VPN connectivity between your VPC and your on-premises environment. Another good feature is resource level permission. So either you talk about the entire instance, or you talk about what level of security you wanted to have. You can create the IAM roles, and you can assign them according to your requirement. In case you wanted an IAM role to launch an Aurora instance, so it will be given that permission. If you wanted to have the configurational changes, so you can assign another IAM role to do that. So you have uh, the uh, the fine-grained control over it. You have the encryption both at rest and in transit, so it is very good. Fully managed, it is easy to use. It is just a push button. You can create the instance, you can manage it, start and stop. Everything is good. In terms of monitoring and matrices, you have CloudWatch. For the database, you can have the database insights. So I think there are some 50 metrics which can be used. You have automatic software patching as usual in the cloud environment. You can have the SNS enabled, so you can get the events notified during the database insights. You can clone your database if you have the snapshots available, so you can have it shipped in another region, and you can do it over there. You can very easily start and stop the cluster. In terms of the migration support, since this is PostgreSQL compatible, so you can have your native tool used, which is pgdump and pgrestore. You can have the export import. The way it is working in Postgre environment, the same will work over here. If you wanted to bring some heterogeneous environment databases to here, you can use DMS, which is very fast and good. And you want to convert some of the enterprise databases, they can be converted using the DMS, which is database migration services tool. And the next one is cost effectiveness. uh, like any other cloud resource, it is you pay for what you use, and you can optimize the IO cost. This is very important. Each read and write operations in case of Postgre Aurora, it is 8 KB and 4 KB respectively. So what happens? So if there are multiple writes which has to return onto the SSD, which is the disk, then it will combine all of them, and the write operations will be be combined as less usage of IO. So each read operations that is assumed as one IO operations. So because of the intelligent hardware, your read and write operations are faster. This is very good. So Aurora PostgreSQL can be integrated with your machine learning capability, so you don't have to do anything extra. So you can enable to have the machine learning based prediction to your application via the SQL programming language. So you have another good feature, which is RDS proxy support. So RDS proxy support is a fully managed, highly available database proxy, wherein what it will do is, it is in case of there is a database failure, so RDS proxy will allow applications to pool and share the connections established with the database. So it reduces the failover time by connecting to the new database instance. So it is just like kind of pooling kind, which can fail over to the available instance. And I hope this is going to help, and thanks for